Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 52 in our incredible new tutorial series where you're unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your gear, but if you don't, look down in the description. There is a link over to Amazon. You can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is we're kind of starting a new part of the class, and what I am going to show you how to do is how to use the NeoPixel strips with the Raspberry Pi Pico W. And so this, I've actually been playing around with this for the last couple of days, and I have been having a lot of fun. And I hope you enjoy playing around with these LED strips as much as I do. So let's just jump right in and let me show you what you need. You need to get out your kit. I think I need to get out of your way. You need to get out your kit and you need to find this NeoPixel strip. Now what you will see is this particular strip that is included in the kit has 8 LED. It's a strip with 8 LEDs. Now you're probably thinking about running a lot of wires and all of this complex stuff, but it is really amazing how these NeoPixels work, and it's really amazing how simply they work. You can see that we're going to be able to individually control 8 LED from simply 3 wires. The red wire, the wire on the top, and you can see it's also labeled here, that is 5 volts. So that 5 volts comes over when you are oriented like I am down to the lower right. The lower right is physical pin 40, and that is a plus 5 volts. Then we come over to physical pin 38, so we skip 39. 38 is a ground, so now we have power and now we have ground. And so that is the red and that is the black wire. Then the yellow wire is data, and we connect the data pin to physical pin 1, which is GPIO pin 0 on the Raspberry Pi Pico W. So it is very, very easy to hook up. Now, before we jump in and program it, I'll also tell you that it's really easy to program. But before we program it up, I want you to kind of understand how this works, because it's really, really very clever the way they build these NeoPixel strips. So let's switch over to this diagram, and what I have in this diagram is this diagram shows you how these things are hooked together. And in this array here that I am demonstrating, that I've drawn out, I'm showing for 3 pixels, but the concept is the same whether you're dealing with 3 or you're dealing with a strip of 100. And what you can see is, remember over on our NeoPixel, I showed you that we had 3 wires. One was 5 volts. And what you're going to see here is, you have the 5 volts here, but that 5 volts just goes all the way down and it feeds every single NeoPixel just with a 5 volt bus. And so that strip that you have of NeoPixels, it has a 5 volt bus, and each individual pixel picks its power off of the 5 volt bus. And similarly, you have a ground bus. And so every NeoPixel is connected to the common ground rail. So you have a power rail, a power bus, and you have a ground rail or a ground bus. Okay, so that's 2. Now this is where it gets interesting. The third one is that middle pin is the data. Okay, it is the data. And what you pass it is you pass it the color in one array. You're going to pass it an array that tells it what color you want each pixel. The first pixel, second pixel, third pixel. Okay, up to 100 pixels if you had that. And so when we look here and we start with this data in, what do we pass it? Well, we have 3. And so let's say that we want the first one to be R, we want the second one to be G, and we want the third one to be B. We want a red, a green, and a blue on pixel 1, 2, 3. So what we would do is we would pass it. The first one, red, would be 255. So 255 is full strength, then green is 0, and then blue is 0. Okay, and now what do we want the next pixel to be? We want it to be green. And so the red value would be 0, the green value would be 255, and the blue value would be 0. Okay, now we pass it the third, and we want that blue. So that would be 0 red, 0 green, 0, and 255 on the blue. And so we have this data array of tuples, and we pass that over here to the data in. Now, what you also realize, if you played around with the earlier lessons, you know that we could scale the 255, and that would scale brightness. So if we set it at 5, this would be a very, very dim red. Or we could add some red, and we could add some blue, and then we would get a purple. Okay, so we can mix any colors by choosing these, and we can mix their brightness. So do you see with this data structure, we can control every pixel in the NeoPixel strip, and we can control every color of every pixel. And so this is really, really very elegant. Now this is what happens. You have an RGB LED at each position. At each one of these NeoPixels is its own RGB LED, but it also has a very, very simple little control chip at each location. And what that control chip does is it takes in the data in, and so that first pixel takes in this whole array, but then what does it do? It strips off the first one, and so that would be red, and it turns this red, and then what does it pass on? It passes on the balance. Now, what is the next one? The next one is green, and so what does the next pixel do? It strips off the first one, and then what does it do? It passes on the next one, and the first one, in this case, is green. And now what does it do? It passes on the last one, and the last one is blue. And so this comes in, it strips it off, it strips off the blue, and now it doesn't have any data to pass on, but there's no more pixels to pass on to. So is that not like one of the neatest, simplest little data structures you've ever seen? And it makes it incredibly powerful, just absolutely incredibly powerful, because you just build your data structure, you pass it to data in, first one strips, the first one passes on the balance. Strips the first one, passes on the balance. You can also see that every data pixel sort of thinks it's the first one because all the previous data has been taken out. And so each pixel sort of thinks it's the first one. And just our data string, our word, is getting shorter and shorter as it passes through here. So that is how this thing works, and it is incredibly powerful. Now, what you can see is in the device, in the data, or the NeoPixel strip that was included in the kit, there are 8 LED. But what I'm teaching you today, you could do it for 8 or you could do it for 100. Now, how many can you put together? I'm not exactly sure, but you know, people wrap these things around their houses, so you can put a whole lot together. But here is the thing that you have to understand. The issue comes down to power. Okay, how are we powering our strip? We're powering it from the Raspberry Pi Pico W from this 5-volt pin, and the Pico W has very limited current sourcing capabilities. It can only provide a very limited amount of power. So we can safely run 8 pixels, but you wouldn't want to do more than that, because if you tried to do more than that, you would be drawing too much current from that power pin, and you likely would burn out you would likely burn out your Raspberry Pi Pico W. So if you wanted to run a lot, what would you do? Well, the control scheme that I'm showing you will be exactly the same. If you were running a 100 pixel strip, it would be exactly the same as what I'm showing you here. It's just you would not connect this red wire to the Raspberry Pi Pico W. You would get a separate 5-volt DC power supply that was able to provide the current and the power that you need for your number of pixels. Now, what is that? Well, you would have to look at the specs. And so if it said that you had a strip of several hundred of these pixels, and it said that you needed 8 watts to run it, you would need to make sure that your power supply that you hooked the red wire to could source 8 watts, or maybe it listed as a certain current. Well, you would want to make sure that you could provide that level of current from your power supply. Then the other thing is, when you're doing something like that, always remember all your grounds need to be hooked together. So you would need to connect the NeoPixel ground to the Raspberry Pi Pico W ground, and that would also need to be connected to the power supply ground. So when you're powering from one device and controlling from another device, all the grounds need to be in common. All the grounds need to be connected together. So as I progress now, what I'm going to do is I am going to show you how to program this thing up. And just remember, if you're going to do bigger strips, you will just need to have an external power supply. Okay, well, that is how this thing works. And that is pretty straightforward and pretty simple, isn't it? So let's come over and let's see if we can get started on this. And I want to see if I can just get this going as simple as possible. And you can see up here, I'm trying to leave it where you can see the programming window and you can see the live shot of the pixels. And hopefully you can see my coding. Hopefully my lines of code are not too long, because I really want you to see those pixels well. Okay, so what we're going to do now is we are going to come up here, and already on your MicroPython you should have a library that's called NeoPixels. So we are going to import NeoPixel like that, and that will do a lot of the bookkeeping for us, make it easy to work with this. Now we're also going to be interacting with the GPIO pins, right? We're using GPIO pin 0, so we're going to need to say from machine, we are going to need to import pin like that. And you've got to get your case right. Import uppercase P, lowercase in. Let me see if I can do a little Windows management here. Okay. And then it's always good to import time, because it seems like we usually need to put a delay in there. Okay, now we're going to go ahead and try to set up our NeoPixel. So I need to tell it what the control pin is. So my Pix pin for my Pixel pin is what? It is GPIO pin 0. That was that yellow wire. Now I've got to tell it how many pixels do I have. So I'm going to say pix size is equal to 8. All right. Now I need to create the NeoPixel object. So I'm going to call that pix, and that's going to be equal to NeoPixel, the library.NeoPixel, the method. And now I've got to tell it which pin, right? We imported this pin method. I've got to tell it which pin, and which pin is it? It is Pix pin that I set up like that. Okay. And then I also need to tell it how big it is. And so that will be Pix size, those things that I just set up like that. Okay. Now that all closed out nicely, and you were actually able to see it, and so that looks good. We are doing great here. Now, I'm just going to, let's just see if we can make this thing work. So I'm just going to create a color, and you want to create these colors as tuples, and so I'm just going to say red is equal to 255, 0, 0, like that. Okay, that looks good. And then what I'm going to do is I'm going to say that Pix, that object that I created, that NeoPixel object, that the 0th pixel, right, that would be the first pixel, right, because we start counting from 0, that would be this one, the 0th pixel. I want to set that equal to my tuple red, like that. And then what I want to do is I want to just say pix.right. Now this is kind of like our OLED screen. You're going to do all of this stuff and you're going to forget to say pix right, and then it's not going to work. So always remember, you do all your data manipulation to create that array of colors that you want to put on there. And then what do you have to do? You have to write it, okay? So that's pretty good. Let's turn this on and let's see, could it really be that easy? I can't believe it's that easy, but let's, everyone hold your breath. NeoPixel, what is that? What did I do wrong? What did I do wrong there? That is in, you know what I did? I wasn't connected. I wasn't connected down here, you know, down in the lower right. I wasn't connected to COM3. I was trying to run it locally. So now the real problem was one of you scafflaws didn't hold your breath. So I think you know who you were this time. I need you and everyone else to hold your breath. Boom! Look at that. All right. Is that cool or what? Okay, and guys, I am not going to try to get fancy in making this show better, but it's really a very, very bright and very beautiful red. It's just a very bright and very beautiful and very pure red. Now, what if instead of that 0th pixel, what if I wanted the next one over to turn red? Well, I would change this to 1, and then I would come over here and run. Giddy up. Look at that. Now the next one's turned red. Let's go to pixel 2. Pixel 2. We could turn that red like that. Okay. So you see, I can individually control the pixels. What if I create another color? What if I say that I want green? And green would be equal to the tuple 0, 255, 0, like that. And now let's say that I want to make pix 0 equal to green, and then I have pix 2 equal to red. And so let's look at that. Boom. Okay. The 0th pixel is green, and then this is pixel 1 I didn't turn on, and pixel 2 is red. Okay, I could also incorporate this idea of brightness. And so what if I said brightness equal 0.1, okay? And then what I could do is I could make this, I could scale these times brightness, and I could scale this by times brightness, okay? And this would turn it really down kind of dim by making that 0.1. But I think when you need to do that, you need to go ahead and make those ints, because I think that when you do that multiplication, it's going to make a float, and I think that needs to be an int. So just to be safe, let's make that ints. Okay, so now let's watch it, and we do that, and boom. Do you see now how much dimmer these are, because I introduced this concept of brightness? Okay, so you can not just control the color, but you can control the brightness of that color. So just for ease, I'm just going to go back to the straight full strength. Just wanted to show you that concept of brightness. Okay, so now let me show you another command that you can do. And what I'm going to do is I'm going to comment out that one, and I'm going to comment out that one. And let's go ahead and make blue, okay? And blue is going to be equal to, remember these go RGB, and so R is 0, G is 0, and B is 255, like that, okay? And now what we are going to do is I'm going to show you a new command, and that is pix.fill. And you don't make that an equal, you say pix.fill of what you want to fill it with, and I want to fill it with blue. What is that going to do? I ask you, what is that going to do? Boom, that is going to make the whole thing blue. And I said I wasn't going to do this, but I just can't help it, man. That is such a beautiful, pure blue. And let's see if I cover that up a little bit. You see just what a wonderful blue that is. And man, I'll tell you, these NeoPixels are bright, and so I don't even like staring at them. You can turn it down to like 10%, and they are still just plenty bright. And so I don't even like to stare at those things because they're so bright. Okay, so that is how these things work, that I can control each one. So let's go ahead, let's do a little bit more. So I'm gonna move these. I'm gonna take this. You can't see what I'm doing, can you? Come back over here. I'm gonna take this one out, and let's go back and say, okay, take that out, take that out. So pix 0 is going to be red. Pix 1 is going to be green, and then pix 2 is going to be equal to a blue, like that. Okay, pix 2 is going to be equal to blue. And now let's also make cyan is equal to, that is equal to 0 red, 255 green, and 255 blue. That cyan is mixing green and blue. Magenta is mixing red with blue. And an equal sign there would be useful. Okay. Cyan, magenta, and yellow is going to be equal to mixing red. And we mix red with green. And sometimes to get it perfect, you want to tweak those colors a little bit. But now we have red, green, blue, cyan, magenta, yellow. And what that's 1, 2, 3, 4, 5, 6. Let's go ahead and let's make an orange. Orange is equal to, we want red at 255. And what would that be? That would be a lot less green. So let's say 100 green and 0. That's just kind of a guess that the more green you have, the more yellow that it becomes. And so if we turn the green down, you should move closer to red, which should be orange if I'm thinking about this right. Okay, so that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And then let's just say white and see how close we can get on that. And white is all red, all green, red, all blue. So that would be 255, 255, 255, like that. Okay, so pix 0 is red, pix 1 is green, pix 2 is blue, pix 3 is cyan, pix 4 is magenta, pix 5 is yellow, pix 6 is orange, pix 7 is white, like that. Okay, and then we've got the right in there. So I will need everyone, that got a little not perfectly straight, and right, we cannot have that not perfectly straight. There. Okay, so I need everyone to hold their breath. Giddy up, look at that. Red, green, blue, cyan, magenta, yellow, orange, and white. And man, that is a beautiful orange. It's a beautiful orange when you look at it with your with the naked eye. But as you guys know that have been playing along in this class, it's hard to get the camera to capture the colors like they look to the eye. But you guys that are playing along at home, you already know that, don't you? So that is just pretty darn cool. So you can see that I can control individually the color of every pixel. And you can also see that if you had a really long string of these, it's just a matter of defining more pixels. So what I want you guys to do is I want you guys to kind of get comfortable with this and play around with it a little bit. And let me see here. Let's see if I can go over here. Give me just a second to see if I can show you your homework assignment. I want you guys to go in and kind of get comfortable playing with this thing. So I got to see if I can come over here. And this is what I want you to do is I want you to go in and sort of see if you can make something like this. Okay. And what do you see? You see the green. You see you have a field of green, and then you've kind of got the running, you've got a field of red and you've got a running green. Okay, you've got a field of red and you have a running green. Is that really what I want? Yeah, I think that's what I want. And so you can see that it runs back and forth, it hits the edge and it bounces off. And so I just want you to now kind of get comfortable with playing with these data structures so that you could create some really, really awesome patterns on your NeoPixel array. So as a homework assignment, you have to kind of at least do this, or in addition to this, you can go in and you can do something even more snazzy and even more flashy. And then what you need to do is you need to make a little recording of what you've done. You need to post it to YouTube. In the description, link back to this video so people know what you're talking about. And in the comments down below, then link to your homework solutions. And I tell you guys, I look at every single homework solution that you guys do. I go in and I look at your homeworks. I love it when some of you guys really kind of take the homework to the next level. And that's what I'm hoping some of you guys will do. Now we're going to do another couple of lessons on these NeoPixels because guys, you can go to Amazon and for like 20 bucks, you can buy these huge long strings of these NeoPixels, and literally people just like wrap their houses in them. And you can do some really, really pretty impressive and amazing things with these. And so I want us to spend a couple of weeks on this NeoPixel array and just see what types of cool things we can do with it. Okay, guys, I hope you are enjoying taking these lessons as much as I am making them. As always, I want to give a shout out to you guys who are standing with me on Patreon. You guys that are helping out on Patreon, you're what's keeping me in the game and you're what's keeping this great content coming. Appreciate you guys. And you can also help me by giving me a thumbs up. If you haven't already, subscribe to the channel. When you subscribe, make sure you ring that bell so you will get notifications of future lessons. And as always, share this video with other people because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.